Okay, welcome to the next lecture on this microprocessors. Still, we are in the introduction stage. We are building a foundation for this entire course. So, what we have discussed in the previous class is what is the difference between a microprocessor, a microcomputer, and a microcontroller. Okay. So, microcomputer we have defined that computer in which the microprocessor is the CPU, or the CPU is replaced with a microprocessor, so we call that as a microcomputer. Okay, so we have a structure like this. So if you see a computer system, so in that you have a CPU, central processing unit, which itself has different units: the ALU, the register unit, and then a control unit. Okay, this is what is inside basically CPU. And then we have memory. So memory, we are talking here about the primary memory, not the storage devices like hard disks or your CD, DVDs or pen drives. They are also memories, no doubt. They are storage devices, but they are secondary storage devices. The memory that we talk about here, it is the RAM and ROM, read-write memory and read-only memory. Okay, which are used to store the data and the instructions, or the data and the programs. And then we have a input-output system. So the input output and this CPU, they are controlled, or they are connected with each other using a group of wires which is called as buses. And similarly, memory and your CPU, they also communicate through these wires which is called as bus. Okay, so later on we will see that this system bus, it is categorized into three categories. We have address bus, data bus, and control bus. But this is what is the general structure of a computer. Okay, so the microprocessor is the controlling unit. It controls the memory element as well as the input output devices. Okay, so you can see there is no direct connection between input output and memory. Okay, so whatever data you enter from the input device, maybe keyboard or a mouse or a switch, whatever it is, it will go inside the processor, and then from there it will go to the memory. Similarly, if you want to display something on this output device, maybe a monitor or a LED display or 7-segment display, whatever it is, a printer, so the data will be taken from the memory, but the processor is controlling it. Okay, it will be sent to the output device by the processor. It will not directly come from the memory to the input output. Okay, so if this will happen, so every data will come itself on the monitor. Okay, without the knowledge of processor. So that should not happen. So that is why the processor controls the whole circuitry in the computers. Okay, so CPU is the major part of any computer. So all the arithmetic and logic operations, they are done within this block. Okay, so whatever data you provide, input data, maybe from a keyboard. So if you would write 2 plus 3, so it is the processor which is reading those instructions and executing those. It is not the keyboard. So keyboard is just input device. Okay, and in fact what is stored in the memory, that is the binary code of these. So generally we in your computers we use the ASCII codes. So you may be aware of this. It is a 7-bit code. So all your numbers and letters and special characters, they are assigned a unique code. Okay, so whenever you press any key, so the corresponding ASCII code of that basically goes to the memory. Okay, so this is what we have discussed, I think, in the previous class also. And then we have said, okay, in 1971, the term microprocessor came. Okay, where all these blocks, ALU, register unit, and the control unit, they were assembled or they were integrated on a single silicon chip, on a single integrated circuit. So the term came microprocessor. So they started it from 4-bit processor, then it upgraded it to 8 bits, and then there are different versions of 8 bits, of course. And then from 8-bit to you got 16-bit processors, then 32-bit, 64-bit. Okay, so right now you are using I-core 7 processors. So they are very fast processors. Of course, the processor that we will discuss is a 8-bit microprocessor, which is devised by the Intel, that is 8085. Okay. And then came the term microcontroller. So microcontroller is basically a complete microcomputer in which the processor, the memory, the input output ports, they are all integrated on a single chip. Okay, and then we have discussed what is basically embedded system and what is the reprogrammable system. So in the embedded system, your microprocessor or the controller is the final part of a product. So it is not available to the end user for reprogramming. Okay, so you may have a remote control. Okay, so in the remote control, you have a microprocessor or a microcontroller. So that is the embedded system. So once you press any key, the processor will understand the meaning of those key. It will send a signal to maybe a TV or a AC, and according to those instructions are executed. Okay, similarly in your washing machines, dishwashers, traffic light controllers, so all they come under the category of embedded systems because they are all microprocessor or controller based systems, and you have defined or you have burned a specific program for a specific application. Okay, so in that case, the microprocessor or the controller is used to do one and only one task. Okay, but in general purpose computing, so you have a microprocessor that can be used for performing various tasks. Okay, so that is what is a reprogrammable system. Okay, now we will discuss about this microprocessor, or in short we will write it as MUP. So how the microprocessor works basically. So for every microprocessor there is a set of instructions which the processor can understand and it can execute. Okay, so the set of all those binary instructions is called as an instruction set of the microprocessor. Okay, and how actually it is done. So you store the data in the memory. Okay, so in the memory you store instructions as well as data, or you can say it is a program instruction set of instructions. You can say the program and the data, they are both stored in the memory. So memory is nothing but it is a storage device. Okay, so we use flip-flops generally for the static RAM. So we use flip-flops to store these bits or the data in the memory. A group of flip-flops that becomes a register. So you may have a 8-bit register. So it means you can store 8-bit information in one location. So this may be 8-bit register, 8-bit. This is another 8-bit register and so on. Okay, so you have millions and millions of locations in this. So you can store any binary information in it. Okay. Now whatever binary information you store or whatever data you store basically in the memory, it is in the binary form. It is just a pattern of zeros and ones. Okay. It may be a song you're storing in a memory. It may be video. It may be some image. It may be anything. Okay. Maybe a Word file. So how the microprocessor is going to understand that whether you are storing a song in the memory or whether you are going to store an image in the memory, because finally see in every way at the final stage the data that you store in the memory is binary. So how it will understand? So this will not understand whether you store a song or whether you store a movie or you store an image. The processor will not care about this. It will just look to the data as a binary data. Okay, and how you store this data or how you read this data from the memory, that may be a question. So for that, see, if you say a memory, which is a storage device, so we have different locations. Okay, each one location has a particular capacity to store certain fixed number of bits. Let us suppose it is a 8-bit storage. Okay, it means at every location you can store now 8-bit data. Okay, so since there are different locations where you are going to store this information, so you must have something to identify those locations. That is what is called as the address. Okay, so each memory location has a specific address. So that address identifies that from which location you are going to read the data or on which locations you are going to write the data. Okay, so if you have, so that depends upon the number of address lines now. Okay, so if you have 2-bit address, so you can have 000111011. Okay, so you can have a memory of maybe 4-byte size. Okay, say 4 locations basically, and if each location stores 8-bit data, so you have 4 bytes. Okay, similarly for 3 bits you can have 8 combinations, so you have 8, you can store 8 bytes of data and so on. So if you have 16-bit address, so you can have 2 to the power 16, which is 64 kilobytes. So 64 key locations, they can be identified using 16-bit address bus, right? So every location in the memory has a unique address. Okay, and when you write some data into the memory or when you read some data from the memory, it is written or at once. No, it is written memory by or location by location. You are not, if you store a song in the memory, it is not going to store at once. Okay, it will be done in a sequential way. Okay, so you'll fill the first location 8 bits, then the next 8 bits, and so on. Okay, and how it is done? For that, the microprocessor will have we will come to this later on also. There are 3 buses. One is your address bus, one is the data bus, which is a bidirectional bus, and one is control bus, which is used to send some control signals from the processor to the memory or other peripherals that are connected. Okay, so let us suppose I have some memory, and assuming that you have a 16-bit address bus, it means your address can start from 0000H up to the last location will be FFFFH. Okay, so let us suppose at this location I want to store some data, and that data is suppose 25. Okay, it means I want to perform a write operation. Okay, so what I will have to do is first, on the microprocessor, what it will do, it will first identify the location of this memory where you want to write this data. Okay, and how that is located, that is located by your address bus. Okay, so address bus basically carries the address of the memory location from which you are going to read the data or you are going to write the data. Nothing else. It does not carry the data. Okay, it is simply used to carry the address of the memory location. So if 0000 is the address of the memory location, that has to be placed on the address bus. Okay, so the processor will place that address on this address bus, and now okay, this location is identified. Okay, Now if you want to write some data into this, suppose that data is 25. So in the next stage, what will happen, that data will be now placed on the data bus. Okay. Once you place this data on the data bus, then the processor will send a control signal which is called as write. Okay. So this will give a command which is write, and whatever data is stored on this data bus, that will go inside the memory at this location 25. This is how we write this data into the memory. Okay, so the first thing is that you have to load the address of this memory location on the address bus. The processor will load the address, so that location is identified, and then the data is placed on the data bus, and a control signal is given using control bus, which is a write signal, and that data is written in the memory. Okay, similarly for a read operation, suppose you have a memory location 2000H, 20,000H, and it is some data in this place, suppose it is 3F. I want to read this data from the memory. Okay, so what is the process now? So first thing is you have to identify this address. Okay, so from which location you are going to fetch this data. So that data, so that address or that location is basically identified by this address bus. Now again, the address bus basically this 200H, which is not but a data but basically address of the location from which you are going to read the data. Okay, so once the processor places this address 20,000H on the address bus, so this location gets identified. Okay, this is the location from which we are going to read the data. Okay, then what is the next? Okay, will you place the data on the data bus? No, because you have no information about the data. Okay, if you already know what the data you want to get, then there is no need for this read operation. Okay, the next what the processor will do, it will send another control signal which is a read signal using control lines. Okay, that I want to read the data from this location. So once this signal is activated, which is active low signal basically, that is why we have a bar over it. We will discuss the pin diagram in detail. You will get more clear. So the address is identified using the address bus. Okay, and then the microprocessor will send a control signal that is read. So once it sends the control signal read, whatever data is located at that location, which is identified by your address bus, so that data is placed on the data bus and it comes inside the microprocessor. Okay, this is how we read and write the data from the memory. So there is a specific difference in reading and the write operation that you can identify. Okay, so in the write you have to place the address on this address bus, and then you have to place the data on the data bus, and then you have to send the control signal to the write. Okay, in the read operation you have to first identify the memory location using the address which has to be placed on the address bus. Then the microprocessor will send a control signal that is read, and whatever data is at that particular memory location, that will come on the data bus and it will go inside the microprocessor. Okay, so you have so this is how you can identify the memory locations. So you have a specific address for each location. Okay, so it means if you have two 16-bit address bus, so you can identify, and each memory location, if it is 1 byte in size, so you can have 64 kilobytes of memory that you can interface with the processor, in fact. Okay, but it is not necessary that okay you always use 64 kilobytes. You may attach 4 kilobytes or 8 kilobytes or whatever you want. Okay, but this is the maximum, you can say, capacity of this processor if it is if it has 16-bit address bus, so it can locate 64 k different locations. Okay, so your instruction and the data, they are both stored in the memory. Okay, So whether it is a program, whether it is data, both will be stored in the memory. Okay, so like suppose if you have any in your mobiles, if you have used any apps, so your song is basically data, and the player that we use for playing the song, it may be a VLC player or any other player, so that is a program. Okay, similarly your Microsoft Word is a program, and whatever you write in that, that is a data. Okay, so now you can understand how it is when you save a file. If you are supposed to open a Word file in the computer and you have written something text and then you have saved it. Okay, now how that data is saved, that is done by using this write operation. Okay, so file is saved means all the data is stored at a particular location in the memory. Okay, so the processor will identify some address, and then it will convert those letters into ASCII codes, and then their corresponding codes, they are basically stored. Okay, and when you open this file again, so the data from that location is basically retrieved and it is displayed. Okay, but this read and the write both are not done at once, although it is done in a very fast way, that most of the these processors, they do this operation in fraction of seconds. Okay, so you are not going to realize whether the data is stored location by location or it is stored at once, but it is done basically location by location. Every time we have to store, read or write, you have to send some control signals for each location. It is not for the entire memory. Okay, this is how your read and write operations are done. So this is what is memory basically. Okay, so you have a storage device which has unique addresses, and at each address either the processor can write some data into the address, or it is going to read some data from that memory location. Okay, and for that we have special buses which are called as control bus. The purpose of the control bus is simply to send some control signals. Okay, so there are many other control signals, no doubt, but these are two primary signals, read and the write. So when we discuss the timing diagrams, it will be more clear to you. Okay, so data bus is bidirectional. Okay, it is used to take the data from the processor to the memory, and also from the memory to the processor. Okay, but your address bus is unidirectional. Okay, it only carries the data from the processor to the memory, or processor to some maybe input output ports. Okay, so it is not bidirectional. Okay, and memory, see, you may be aware of this, but let me revise it. If you see the size of the memory, since we are dealing with the binary numbers, so everything is in the powers of 2. Okay, so if you have 2 to the power 0, 2 to the power 1, 2, 3, 4, 5, 6, 7, 8, 2 to the power 9, 2 to the power 10. Okay, of course this is 1, then this is 2, 4, 8, 16, 32, 64, 128, and so on. So this is what is called as 1 byte, and 2 bytes, 2 to the power 1, 2 to the power 4 is 4 bytes, 8 bytes, 16 bytes, 32 bytes, and so on. So when it comes to 2 to the power 10, it is called as, it is 1024 is the actual value, so we call it as 1 KB, 1 kilobyte. Okay, it is not exactly what we use in the decimal. 1 kilo means 1000, but in binary, in case of these memories, we use 1024 as 1 kilo because it is the closest approximation of, you can say, 1000 in the decimals. Okay, similarly, if you have, say, I have a memory of size 2 to the power 12, so what it means, now you can separate 2 and 2 to the power 10. So 2 to the power 10 is your 1 KB, so it is nothing but 4 KB. Okay, similarly 2 to the power 15 if I have, so it is 2 to the power 5 into 2 to the power 10, so 2 to the power 5 is 32, and this is 1K, so it is 32K. Okay, similarly when you go up to 2 to the power 20, after every powers increment in the powers of 10, you go to the next stage. So it is basically 2 to the power 10 into 2 to the power 10 So it is 1k into 1k. Okay, so we could call it as 1m, 1 mega. Okay, similarly, so if you have 2 to the power suppose 23, so it means it is 2 to the power 3 into 2 to the power 20, sorry, 2 to the power 20. So it is 1 mega, and 2 to the power 3 is 8, so it is 8 MB. Okay, so when it comes to 2 to the power 30, we call it as 1 GB, 1 gigabyte. Okay, and similarly when it comes to 2 to the power 40, we call it as 1 TB, 1 terabyte. Okay, so this is how the memories, you can say they are identified, the size of the memory. Okay, so right now you are using mobile phones. I have 128 GB of this memory or 256 GB, so that you can now see how much space you have in your devices. Okay, so now see now how the microprocessor will work, how it will execute each instruction. So there are 3 cycles basically. So you have microprocessor, and now you have a memory which stores instructions as well as the data, and the communication between them is done through some buses, which is one is address bus, then we have data bus, and then we have control bus. Okay, so suppose you have some program or some instruction or some data which is already written in this memory. Okay, so how you write or how you read this data from the memory, so that we have discussed. Okay, and now see actually how you burn that data or how you put the data in this memory, that is a separate issue. We will come to this later on. So let us suppose that you have some instructions and data which is already stored in this memory. Okay, and all the instructions, they are nothing but the binary codes which we call as the machine codes. Okay, so each code has a specific meaning which is called as basically operation code, or we call it as opcode in short. Operation code. So operation code is a binary code. It may be 8-bit code or whatever it is, 16-bit code, depending upon what is the word length of the processor. Okay, so as a simple example, suppose I take a 2-bit processor. Okay, so 2-bit processor means you can have 4 codes, 0 0 0 1 1 0 and 1 1. Okay, so each code has now a specific meaning. The microprocessor will understand, or it is giving a specific meaning to each of these binary codes. Okay, so let us suppose, for example, this code is used for operation of addition, this is used for subtraction, this is used for multiplication, and this is used for division. Okay, it means what is the power or the computing power or the capability of the processor is that it can only do 4 operations. Either it can add 2 numbers or subtract or multiply or divide. Okay, so one of these codes that has to be put inside the memory using some mechanism. Okay, that we will come to know later. So if at this location I have supposed 0 0, so it means it is an instruction for addition. At this location, if I again have 0 0, it is an instruction for addition. So I have one next location, if the code is 1 1, it is an instruction for division, and so on. Okay, so all the operation codes or opcodes, they are stored in the memory. Now how these codes, operation codes, they are executed. Okay, so the processor, it basically performs 3 operations. One is fetch, another is decode, another is execute, and these are performed for each instruction. This is called as instruction set, also instruction cycle also. Okay, So first what it will do, the first operation that the processor will do, it will fetch this instruction from the memory. Okay, and how it is fetched? For that you have to first identify the memory location from which you are going to fetch these instructions, and that is done by the address bus. So you place some address on the, later on when we will see the architecture, you will see there is a special register for this which is called the program counter. So the program counter, it holds the address of the memory location from which you are going to fetch the next byte. Okay, but anyway, for the time being, so you identify the address of this memory using address bus. Okay, so you place the address, or the processor places the address on the address bus, and a particular location is selected. Okay, then you have to fetch this data. Okay, so this may be data, this may be instruction also. So you fetch this instruction from this memory. So for that you have to do a read operation. It means the processor will now send a control signal, that is read, to this memory, and whatever the instruction is at that location, that binary code, it will come on the data bus and it will go inside the processor. Okay, so the processor will first place the address on the address bus, it will identify the memory location, then it will send a control signal, that is read, to the memory, and whatever data is stored at that location, whatever binary pattern is stored at that location, that will be placed on the data bus and it will come inside the processor. This is what is called as fetch. Okay, so you have fetched the instruction from the memory. So this part is okay. Okay, so you have taken the data from the memory inside the processor in the first part. In the next part, what the processor will do, it will decode now this data. Okay, now this is very important thing. There is a separate decoder inside this processor which is called as an instruction decoder. Now see, you have a binary data, it is coming inside the processor. What the processor has to do, it has to understand this. What is the meaning of this binary pattern? Okay, because based on that, then only it will going to the third step, that is execution. Okay, so what you mean by decoding is to understand this instruction, that what operation is to be done by this microprocessor. Okay, it means, say, if you are placing the 00, if the 00 is the instruction on this at this memory location, and if that is placed on the data bus and it goes inside the processor it gives this instruction to a decoder. The decoder will decode this instruction, okay, or it will understand the meaning, what is the meaning of this instruction, what I am supposed to do now. Okay, so that is what is done in the decoding part. Okay, so the microprocessor will come to know that, okay, what operation it has to be performed. Okay, what is the meaning of this instruction, that is done in the decoding unit. Okay, and then finally you have the execute. So it will understand the meaning of that binary code or the binary pattern, and accordingly it will execute it. Now how the execution is basically done, so you have a microprocessor, let me make it more simple. So you have you have a address bus, you have located a address. So on that address you have some binary data. So that data is now placed on this data bus. It has gone inside the microprocessor. Okay, so it basically goes to a special register which is called as an instruction register. We will come to this later on when we will discuss this in the architecture of the processor. So this instruction goes inside this register first, instruction registers. So from the instruction register it will, this is what is fetch part. Okay, so you place the address on the address bus, the location is identified, the data is placed on the data bus, it has come inside the processor in the instruction register, and then you have an instruction decoder ID, I say it simply. Now this instruction decoder will decode this, that what is the meaning of this instruction. Like for this case, a very simple example I have taken. So it means there is a circuit for addition, there is a circuit for subtraction, multiplication and division, which is already there. Okay, So in the processor, you have a circuit for adding two numbers, or for subtracting, or for multiplying, or for dividing. Okay. So if 00 is the instruction at this location, and if that is executed, that is fetched, what the instruction decoder will do? It will trigger a particular logic circuit. Okay. It means if 00 will come from the memory, this binary pattern, the instruction is decoded in the ID unit, instruction decoder. It will come to know that okay, it has to perform a operation of addition. So accordingly, it will trigger a adder circuit, which is be used to add two numbers. So if at next stage you suppose have a instruction 10, and if you fetch this instruction, it goes to the decoder will understand this instruction that the purpose of this is to multiply, so it will trigger this unit. So at a time, one of these units is basically triggered. So these are all hardware logic circuits, they are designed. Okay, but which is to be controlled or triggered, that depends upon that what instruction you're getting from the memory. Okay, so of course in the large processors, this is just a systematic diagram to understand what is the meaning of this fetch, decode, and execute. Okay, so you fetch an instruction from the memory, the processor decodes it. It means it understands this instruction that what has to be done. Okay, and then finally it sends some control signal to a particular functional module in the circuit which does those operation that is desired. Okay, so this is what is called this is very important, and this is done at the design stage only, which is called as microprogramming. We call this as microprogramming. Microprogramming. So microprogramming means what binary pattern is used for what purpose, that is decided at the design level. It means if you have an 8-bit now processor, okay, so if you have 8-bit processor, so in the 8 bits you can have 2 to the power 8, that is 256, 2 to the power 8, which is 256-bit patterns. So you can have 0 0 0 0 0 0 0 0 up to 1 1 1 1 1 1 1 1. Of course we use in hexadecimal, this is 0 0 H, this is FF H. Okay, it means how many operations the processor can do is the maximum is 256, not beyond that. Okay, this is what is the what decides the computing power or the capability of the processor. Okay, it cannot do more than 256 operations because we have only 256 unique codes, and each unique code must be assigned a particular meaning. Okay, so it may be possible, suppose for addition of two numbers, if you have to add a, there is a register A, and you have to add the contents of A with B and put this back into A. So the designer may have used a specific code for this, that suppose it is 01011011, maybe. This is not the actual code, I'm just taking an example. Okay, so this binary code is a machine code for the addition of two numbers, in which one number is stored in the register A and another number is stored in register B, and after addition the two they are get added and that result is stored back again in A. This is a machine code, a binary pattern. Now if you put this machine code in the memory, okay, and when you fetch it, you first fetch it, it will go inside the processor, then you decode it. The processor will decode it, it means it will understand what has to be done, what is the meaning of this bit pattern. So it will decode it and it will come to know that okay, the purpose of this is to add two numbers which are in A and B. Okay, and then it will execute it. Okay, it means it will now trigger, or it will generate this clock signal which is used to activate the adder circuit, and the input data for that must be in A and B. Okay, so this is what is decided by the design engineers, that which bit pattern they want to use for which purpose. Okay, so that is why a machine language is machine dependent. Okay, it means whatever is the machine code for one processor, that is not basically compatible for the another processor, because they are designed by different engineers, and it may be possible that okay, in one processor you have used this code for addition, in another code for the same operation they may have to use a different codes. Okay, so in the one more processor, this may be the binary code or the machine code for addition of two numbers in A and B. So that is why when you write a program in the machine language, they are not basically transferable, okay, or they are not executable. So one machine code for one processor, that is not transferable to the another processor by different manufacturers, because their machine codes are different. Okay, and when you do the programming, we do not do the programming in the machine language because it is very troublesome, and there are chances of so many errors. You cannot just go on typing zeros and ones and zeros and ones and writing the codes like this. Okay, so for that we have developed some more, you can say, good languages, like we have high level languages or assembly languages. So we write a program in just English like words, and then there are softwares for that. We have compiler for the C and assembler for the assembly language, which automatically converts that assembly language or the C program into a machine code. Okay, but this is what is the overview of this. How is machine? What is machine code, and how the processor fetches, decodes, and executes these instructions. Okay, so the machine code is very important. For each instruction, you have particular bit pattern, which is called the machine code. Okay, and once the processor gets this code from this memory, it decodes it this codes, and by decoding we mean that what the processor comes to know that okay, I have to perform this operation. Okay, and how that operation is performed now, for that you must have some logic circuit for that. Okay, so that is already in the ALU, so that has to be activated, so that is activated by using some clock signals. Okay, so once it gets activated, so that operation is done, and then this is a sequential procedure. So you go from the once one instruction is complete, means fetch, decode, and execute, you go to the next instruction, again fetch, decode, and execute, go to the next instruction, fetch, decode, execute, and so on. So you go on, the processor will go on doing like this unless and until it comes to a instruction where it is supposed to stop the program. Okay, so we will continue further in the next lecture.